Hi everyone, in this video I would like to speak about 3D printing technology. First to say about myself, I'm Chamundeshwar, pursuing my third year BTech in Mechanical Engineering from IIT Mundi. This video is made with computer synthesized voice. Okay, let's begin. 3D printing is a process of making a three-dimensional solid object of virtually any shape from a digital model. 3D printing is achieved using an additive process where successive layers of material are laid down in different shapes. That is, the object is printed layer by layer, one on top of other, to get a complete object. 3D printing is considered distinct from traditional machining techniques, which mostly rely on the removal of material by methods such as cutting or drilling. The first working 3D printer was created in 1984 by Chuck Hull of 3D Systems Corp. This man is most often credited with inventing the language of modern 3D printer. He first patented the term stereolithography, defined a system for generating three-dimensional objects by creating a cross-sectional pattern of the object to be formed. So let's see how this 3D printing works. The first thing is the modeling, where we take virtual blueprints from computer-aided design CAD or animation modeling software and slice them into digital cross-sections for the machine to successively use as a guideline for printing. A standard data interface between CAD software and the machines is the STL file format. An STL file approximates the shape of a part or assembly using triangular facets. Then comes printing. To perform a print, the machine reads the design from an STL file and lays down successive layers of liquid, powder, paper, or sheet material to build the model from a series of cross-sections. These layers, which correspond to the virtual cross-sections from the CAD model, are joined or automatically fused to create the final shape. The primary advantage of this technique is its ability to create almost any shape or geometric feature. There are many technologies to lay material in layers, like fused deposition modeling, selective laser sintering, stereolithography, etc. The most commonly used is the FDM, that is fused deposition modeling. It was developed by S. Scott Crump in the late 1980s and was commercialized in 1990 by Stratasys. With the expiration of patent on this technology, there is now a large open-source development community of this type of 3D printer, like RepRap, and many commercial and DIY variants, which have dropped the cost by 2 orders of magnitude. Fused deposition modeling uses a plastic filament or metal wire that is wound on a coil and unreeled to supply material to an extrusion nozzle, which turns the flow on and off. The nozzle heats to melt the material and can be moved in both horizontal and vertical directions by a numerically controlled mechanism that is directly controlled by a computer-aided manufacturing (CAM) software package. The model or part is produced by extruding small beads of thermoplastic material to form layers, as the material hardens immediately after extrusion from the nozzle. Stepper motors or servo motors are typically employed to move the extrusion head. It uses various polymers, like acrylonitropbutadiene styrene, ABS, polycarbonate, PC, or polylactic acid, PLA. I personally tried making one myself with the help of RepRap community. This is the 3D printer which I made myself. It's based on the FDM technique. It uses PLA's fill material and got a resolution of 500 microns. Its unique design and open-source components help it to reduce the cost drastically, bringing it down to $10,000 to $15,000, which is very low compared to commercially available ones costing more than $1 lakh. Work is going on it to make a better version with better resolution. For more details on 3D printing, you can follow up with the RepRap community or talk to me at chaman@live.in. Thank you. This recording was created using spoken text.